As roommates, we constantly argue about who won the most recent ping pong point. So we decided to get an unbiased third party artificial intelligence referee to decide for us instead. I challenge you to a duel.
A best of 3 match?
Yeah.
Player 2 scored. Player 2 wins the point faster than my internet connection drops out. And that's saying something, folks.
Oh, man. I wish I could come up with insults like that.
Wow. This AI has some wit, I must say.
Player 1 scored.
Yeah.
Player 1 fires back, doubling the rally count as if they're saying, this ice to warm up. This is war.
Mm-hmm. Exactly.
Man.
Player 1 scored. Player 1 is on a comeback, folks. Seems like they found player 2's weakness. Rallies longer than a goldfish's memory.
Mm-hmm. So it seems like I objectively won this time.
Man.
So you saw our AI referee in action, and so now I'm going to talk a little bit about how it works. And so let me just replay the match that we used in our demo video. And we can see that there's several different sort of feature maps that are used. The first one looks for moving objects. As you can see, my roommate is moving, and this part of the screen is being highlighted in white. Here we have a hue mask, which particularly masks out any reddish looking objects, like this sort of beige door and this floor. And we have this saturation mask, which looks specifically for neon-ish objects or bright objects. And so the combination of each of these looks for moving green neon objects like the ping pong ball that we use. So as we step through this little video, I will additionally note that we have a sort of table detector here, and this works by sort of looking for dark colored sections of the image and extracting quadrilaterals from that. So as I step through, my roommate has the ball right now, and this little blue circle, which appears periodically, will represent detections of the ball. So as you can see, these green large circles represent historical detections, and this blue one represents the current detection. And we see that our model is actually able to use the history of the ball's trajectory to detect when the ball bounces and what direction is moving, as well as what side of the table it's on. So right now this is green, but as it crosses the border, it'll turn a sort of pinkish color. And then when it hits the table on my side, we detect, oh, the ball bounced on the table for player 1. And then it expects me to return the ball after that. So this is how ball and table detection works. To actually manage game states, what we do is we have a state machine, which if you've taken discrete math 2, we use a discrete finite automata, where we have states like a start state, serving states, states where we expect a player to hit the ball back, and states where we expect the player to sort of like wait for the ball to bounce, I guess, on their side. And so this manages the whole sort of mechanics of the game in a really easy to debug fashion, because we can just look through all of these state transitions. And then to add the commentary with the OpenAI API, we have this class that is really quite simple. We just have a system prompt that sort of describes the context of being a sports commentator for a ping pong match with a high capacity for roasting the participants. And we also add additional instructions to keep the commentary short so that we can fit it into a video. And then we just use GPT-4's language modeling API to generate these responses. And we keep a history of the past responses that have been generated so that the AI doesn't reuse comments, and it also can use past commentary to build on future commentary. So this whole combination, this sort of masking approach where we choose parts of the image to detect the ball, polygon detection for locating the table, a state machine for modeling the game mechanics, as well as this GPT API, which sort of provides commentary, is what combines to give us Ultrapong.